Good day, students. Just to say hello to you again as we move on to our very next section in unit number 3. So now as our next example of constructivist approaches to teaching and learning, we're going to look at inquiry-based learning and problem solving. And you will see even from the diagrams that I have above on the slide that these two approaches are really very similar. But our focus is going to be on learning a little bit more about what they are about, and then secondly, looking at the role that they play in terms of the constructivist approaches. So we'll start off by talking about inquiry-based learning. And we really could not start without talking a little bit about a man called John Dewey. He was a very well-known philosopher of education who wrote many books on philosophy and on philosophy, but looking at education specifically from a philosophical point of view. And he's regarded as a true proponent of inquiry-based learning. So what really is inquiry-based learning? Well, it is an approach to learning in which a teacher would pose a puzzling situation, maybe a question or a particular problem, and then the learners would go about gathering the necessary information to respond to the question or the situation or the problem. And ultimately, they would move towards a set of findings or a solution to whatever it is that they were looking for. So now the idea behind this is to get them to be actively involved in searching for the answers rather than a teacher passively telling them about the answer to the particular problem, and also for them to work together collaboratively in the process. So these two, as we know, are the primary ideas that are put forward by the constructivist approach, namely that of working actively together and then also working in a very socially collaborative kind of manner. So in doing so, they would thereby construct their own understanding of knowledge as they move along. So in inquiry-based learning, let's talk about how the process unfolds. So what would start off would be that the teacher would present a particular question, problem, or situation to the learners. And then the learners would start engaging with the teacher and each other about the particular issue at hand. They would then begin investigating, and they'd investigate more about the specific issue than what they might have initially identified. And perhaps over time, when they've been through a lot more investigation, they might find patterns and relationships in terms of their investigation, and these would then be further discussed by the group. And then later on, the learners would share their findings. So this would be an ideal way in which inquiry-based learning would in fact occur. So if we use a very simple example, like how and why do animals communicate? The learners might start off by talking about, right, this is the particular problem we've been presented with, or the question rather that we've been presented with. So let's talk about the kinds of sounds and that animals make and how they communicate with each other. And they might find upon further investigation, for example, if they're investigated how buck communicate with each other, that they tend to move in large groups and that they have sentries stationed on the edge of the groups. Now that is actually part of communication, because somehow through the movements of those sentries and through the noises they might make, they would warn the pack of impending danger. And then there would be those buck who would be searching for food, and they would be communicating in the ways in which they conduct themselves again to the rest of the pack where the good food is to be found. So animals find different ways of communicating, and we find that a lot of it depends on their particular habitat and how they fit in with that habitat in terms of how they're going to communicate that will best serve the particular functions that they might need for the communication. So they would find, after looking at how buck communicate, they might find certain patterns and relationships in the communication that they find amongst buck, which they might even find amongst other animal species as well. So they begin to discuss these various things, and they would then share their findings with each other within the group and ultimately with the whole class, we assume. That's a very, very simple example that I'm using. So if we think about this example now, or we think in general about how the process unfolds, what skills do you believe learners would refine by using inquiry-based learning approach? Think about that for a moment and maybe just jot down a few ideas that come to mind. Well, I'm sure you agree with me that one of the first things that comes to mind is critical thinking. That in a process of inquiry-based learning, it really does help to enhance a learner's critical thinking skills. They learn to research, they learn to analyze, and they also learn to synthesize information from various sources. Sources being places where they found the information, perhaps these are literary sources, but also the sources that they use in terms of their peers whom they are interacting with and the kinds of things that they are talking about. They will learn a lot through collaboration. They will learn a lot through cooperation. And they will also learn to be independent, which you don't find very much in passive learning. So it's one of the very, very useful parts or aspects of learning in a very much more active kind of way is to be independent and to also take responsibility for your own learning. So those might be some of the skills that they would gain through this particular approach. When looking at various levels of inquiry-based learning, depending on a number of variables, the teacher would make a decision on what level of inquiry that he or she would be following. And in one of the videos that I asked you to have a look at, they mentioned 3 different levels. And those levels are structured inquiry, guided inquiry, and open inquiry. So if we talk about a more structured inquiry kind of approach, well, here, of course, the teacher would be a lot more directive and give the actual question or questions and basic instructions for the learner to follow. In guided inquiry, the teacher poses a situation and would guide the learners through prompting questions, pertinent questions that the teacher may ask. When the student asks a question, the teacher may reframe another question or answer with a question in a particular way to steer the learners in the right direction. And it maybe the teacher might provide certain materials which the learners could use. And this could all be used in terms of guiding them in their inquiry-based learning. And then an open inquiry would be a much more open kind of activity, which is certainly happening at a much more higher level of thinking. And we would probably find this a lot more in our more senior grades in the school. So here the learner would establish the actual problem itself and would establish the methods of investigation. And this again would very often happen within a group situation, whether it's done in pairs or whether it's done in a group of a large number of people. So when we consider the variables that a teacher may use to decide on what kind of level of inquiry-based learning would be appropriate, what do you think some of these variables would be that the teacher would need to think about? So I want you to think about that for a moment and just jot down a few ideas on a piece of paper. Well, I'm quite sure you agree with me that one of the issues would be the actual subject itself. certain types of inquiry lend themselves better for certain subjects, and then also for certain topics as well within the curriculum. But I think most importantly, it would be the age and the grade of the learner, because learners might need a little more guidance in the earlier grades, but might need a little less guidance in the more senior grades. So we also then at the same time need to look at the particular class, because some classes need perhaps a little more guidance than others, or some areas of the curriculum might need a little more guidance than others. So there are all these kinds of variables and many more that I think you can think about that would need to be considered when deciding on a particular level of the inquiry-based learning that would be used. Moving on now to talking about problem solving, Woolfolk defines a problem as any situation that you are presented with in which you have to find the means to reach a particular goal. So you're given a situation, you have to now go and develop your particular path to get to the goal of the learning activity. So with problem solving, it's more about finding solutions for problems, and often these are new in the sense that they have not been experienced before. There is a bit of a debate around whether problem-solving strategies are very specific to a subject or whether they are a lot more general, and I don't know what your opinion is around this debate. But if we consider different subjects taught in the curriculum, it might be a little bit clearer. So, for example, if we're looking at subjects like maths, there might be much more specific problem-solving strategies that are appropriate when confronting a particular type of problem. Learners will need to know which specific methods that need to be used, perhaps, or what particular path to follow when trying to solve a particular problem. But if we're looking at general, we know that an activity like reading with understanding is something that is very important and would be used in many, many different subjects, because involved in reading would be the need for the prior knowledge of being able to understand the words, and then also the need for critical thinking as you're going through your reading so that you are able to make some kind of understanding or comprehension of what it is that you're actually using. So definitely there would be more general and more specific examples dealing with problem solving as a type of learning strategy. Now, talking about algorithms, I think some of you, depending on the subjects that you're teaching, might be more familiar with this term algorithm than others. But an algorithm basically is a step-by-step approach to solving a problem. So I have an example here, which is one suggested by Bransford and Stein, which is cited in the Woolfolk book that I'm using for this particular presentation. And they use the acronym IDEAL to identify the 5 steps in problem solving, where the I stands for identify problems and opportunities, the D stands for define goals and represent a problem, the E stands for explore possible strategies, the A stands for anticipate outcomes and act, and then lastly L, look back and learn, or reflect if you like. And those would be the steps involved in using a particular problem-solving approach. So I don't know what your thoughts are on a step-by-step approach to problem solving, but I'm sure you would agree with me that if you're starting in a particular place and you have a problem, you need to have some kind of goal to get you towards a solution. So by having a step-by-step approach, it can certainly be very, very helpful at times. But again, I suppose it depends on the type of problem and the nature of the subject that you are teaching. And because you teach so many, and I'm not familiar with the nature of all of them, it would be difficult for me to find an example for you. So consider an example that would be appropriate within your subject, an algorithm. Now the I stands for identify the problem. So identifying the problem would be the first step. And in fact, finding a solvable problem that turns into an opportunity for learning is even better. And I want to give you an example of a problem that was cited in Woolfolk on page 280. And that is as follows. The machines designed to pick the tomatoes are damaging the tomatoes. So what should we do? Now, the first thing we have to ask ourselves here is, what is the problem here? And then how do we begin to plan to solve this problem from this point? And what exactly is our goal? So having a look at this problem, I'm not sure what you first thought about, but I could definitely first think about the one problem that I found in this particular situation here. And that would be that the machines designed to pick the tomatoes are damaging the tomatoes. Well, the fault must probably lie with the machines, because if the machines are damaging their tomatoes, then we have to fix the machine, or we have to redesign the machine so that it can pick the tomatoes in a proper manner without damaging them. But you know what? Interestingly enough, the more you think about this particular problem, you can think about it from the other way around. And you could say, well, there's something about the tomatoes, maybe it's in terms of their shape or their size, that is in fact now causing havoc with the machines. And the tomatoes need to be redesigned in another way. We need to redesign how we're going to get those tomatoes to grow so that they are not going to be damaged when the machines are picking them up. So this may sound like a weird way of looking at it, but you've got to decide before you start on what the problem actually is, because once you know what it is, then you know what you want to do to solve the problem, and then you have to decide how are you going to actually go about it. D now stands for define goals and represent the problem. So here there is a need to focus attention to the problem, to find it, and then to develop ways in which to find an appropriate solution. So the problems need to present it in a way that learners can understand what is required. The words used, for example, they can't really be at too much of a high level for certain learners to understand, and they have to pertain to the actual subject and the subject area in which you are working. So something that they are obviously used to, are a bit more familiar with. The problem then needs to be seen as a whole, certainly initially, so that the learner has a clearer view of the actual goals that are required. And I want to give you an example here that I've got out of one of the textbooks I refer to. And the problem is this. If you have black socks and white socks in your drawer, mixed in a ratio of 4:5, then how many socks would you have to take out to make sure you have a pair of the same color? So think about that for a moment. Black and white socks in your drawer, ratio 4:5, how many to take out to make a pair of the same color? Well, you'd have to take out 3. And if you don't understand why it's 3, do what I used to do when I was at school, which was to get out a piece of paper and literally draw all the various socks and try and see now how many I'd have to take out to find my pair. But anyway, I got through maths and I did quite well in the end, but that was just one example of what I used at school. But what actually happens here is that in the process of focusing attention on these new problems and in finding new ways of working them out, schema are going to be developed to solve those problems. And as the learners are exposed to further problems, they will obviously refine and extend upon the schema that are developed, because learners come in with existing schema and learners develop new schema as they learn to solve new problems. And so as they get ones that are slightly different from the ones that they initially worked on together, perhaps in class or in their group, they will be able to actually refine those schema that they've developed and even extend upon them as well. So how do teachers educate learners about this? When we're looking at problem solving, how do teachers actually get learners to understand how to solve problems? Well, one of the ways would be to use worked out examples, and they can do so by either having the example worked out on the board to show them, which I think is rather passive, but they could also have examples which they work out with the learners in the class on the board together or in groups, or perhaps as shown here, they would get a learner to come up to the board and actually work it out and explain it to the class while they're doing it. Another thing they could do is to compare different ways of solving a problem. So you might have a geometry problem, for example, but there might be different ways of going about it. We generally start geometry problems with what we know, what we can gain from what we're given. But you can start perhaps at different points of that geometry problem, and you can solve it that way. And then thirdly, another suggestion here is to work from the familiar to the unfamiliar. So when we're working through problem solving with children, we would actually work to familiar examples or similar ones that we've done with them in class. And then we'd start moving into others which they are less familiar with, and finally into novel examples in which they can apply their learning and apply their problem solving techniques to figure out new ways of solving novel problems. And then suggesting a number of strategies that they could use. They might categorize by problem type. They might represent the particular problem using words, pictures, and graphs, because sometimes that actually helps learners to understand. And they could give attention to relevant aspects of the problem. So they could select the particular information that the learners need to focus on that would be helpful for them. So in different subjects that you teach, there might be different examples which you can think about in terms of utilizing these problem-solving approaches. So please keep thinking about that as we go through this presentation together. Now, E stands for Explore Possible Solutions. And here we would look at perhaps some strategies that learners might use to explore these solutions. And one of them would be using algorithms, which are the step-by-step prescriptions for achieving a particular goal. Now, usually algorithms are tied to different subjects and different aspects of those subjects. So if we take, for example, in maths, when we talk about a mean, we all know that if you're finding the mean, what you're doing is you adding up the scores and you're dividing by the total number of scores, and that gives you the mean. But there are so many different algorithms in maths, and what happens sometimes is that learners are using the incorrect algorithm in terms of dealing with a particular problem at hand. So they need to practice and practice various different problems and working out which would be the most appropriate algorithms to use in those situations, which is one of the reasons why I know certainly at grades 11 and 12, where one goes through many, many exam papers over and over again to practice the kinds of appropriate algorithms which would be useful. Then heuristics, which refer to a general strategy that might lead to the correct answer. So a heuristic is more like a rule of thumb, if you like, to make a correct decision. So if, for example, you are busy wanting to grow a tomato plant, there might be a rule of thumb that you would use in terms of making the right decisions to grow that tomato plant. So you'd have to consider where you put it, does it have enough sun? Is it too sunny? Is it too shady? What kind of soil is it, etc., etc. So there might be certain things that are really quite logical that a person could work out in terms of finding a solution and exploring those solutions. Then there's also a backwards working heuristic where we start with a solution and we work backwards to see what the plan we need is, and also if we have all the data that is needed. So, if our solution is to get to a healthy plant, we start off with where do we start from? Well, it's a seed going into the ground, into the right place, etc., etc. But also we can create sub-goals to in terms of a heuristic, where we can break down a larger problem into smaller chunks or problems. Sometimes if you're getting learners to look at something like, say, pollution-based, if you're just talking about pollution in general, well, there's so many different types of pollution. There's air pollution and there's water pollution and there's a whole lot of different types of pollution. So, maybe breaking it down into smaller parts and looking at a very specific aspect of pollution might be a lot more appropriate for the learners. And then analogies can also be very useful at times to solve future problems in the same way as those in the past. So if we look at someone like Alexander Graham Bell, whom I'm sure you all know about, he used his understanding of the human ear and the way in which the eardrum functions and the mechanism of the eardrum in order to design the very, very first telephone. And so that was actually an analogy that he used to understand that telephone and to design one. Then A for anticipating consequences. So here when solving a problem, you need to consider the consequences of your options before you make your final decision. So for example, by making tomatoes tougher, what would be the consequences on the sales of tomatoes? So we've decided the problem was the tomatoes when we had our previous problem of the mechanisms, damaging the tomato. So we make our tomatoes much tougher. Well, are they going to taste as good? Are people going to want to buy these tougher tomatoes and that kind of thing? So we need to start anticipating the consequences of the decisions we make about the problem. So another example there what would be the consequences of having a litter-free school? If the problem is to look at providing solutions to having a litter-free school, well, what would the consequences actually be? And then the L in the ideal, the word ideal stands for looking back. And that's when you evaluate, you need to ask yourself if the path fitted the problem and the goal or solution you want to achieve, and if the solution answered the problem in the first place. So you reflect back on the whole process you've gone through to solve your problem, and if you've in fact been able to do it at the end of the day. So as teachers, we very often need to think about what hinders effective problem solving, because we might find when we try certain things that they don't seem to work very well. And one of the issues is called a mental set, where a person might be locked into a particular way of doing things because of the way in which they've done things in the past. So the situation might be very similar, and so they go about it in a similar way to a past situation. So the example I want to give you there is if, say, you're using a vacuum cleaner, for argument's sake, and you find the vacuum cleaner stopped working. Now, the last few times when the vacuum cleaner stopped working, it was because one of the pipes had become undone. So you realize that you have to now go and check the pipes and see that everything is all in place. But in fact, you do that, and now you find that the vacuum cleaner is still not working. So now you've got to get out of that mental set of thinking it's always about the pipes, but think about what else could it be. Maybe it's to do with the actual vacuum bag that's too full, or maybe it has to do with some kind of electrical connection that's malfunctioned inside the machine of the vacuum cleaner. So we often get forced into, or pushed into rather, thinking about solving problems because of a mental set we have developed over time in previous similar types of problems, but this one might be a little bit different. And another one is functional fixedness, is the inability to see how familiar objects can be used in new ways. So we for example, might tie particular tools in a toolbox to the functions that they actually perform. But in fact, very often those tools can be used for other purposes. If we think about a screwdriver, for example, the other day I was trying to open a can of paint and I thought, now how am I going to open it? Because if I use a knife, I might bend the knife. And then I thought, oh, well, I'll use a screwdriver. I think it's quite a common use for a screwdriver, actually, besides using a screwdriver to drive in screws and to remove screws, is to use it to open a large tin. But I mean, there might be many other uses of a screwdriver. I don't know if you ever used a screwdriver to open a can of something to drink, or you've used a screwdriver because you had to somehow get into your car because you left the keys in your car. And well, that's not something we really want to promote, but anyway, we might be fixed in the way in which we see the functions of that particular article or whatever it may be. The other thing is to let irrelevant information cloud our attention from the original problem. And that is another thing that very often occurs, especially when they give us these very involved kinds of questions, say at grade 10, 11 or 12 level. And I've got an example here to share with you. An airline from France crashes just off the coast of New Jersey within the territorial waters of the USA. Now, although all the passengers and crew were French citizens, none of the survivors was returned to France for burial. So why not? Now, what is the answer to this question or problem? Just have a look at it very, very carefully and think about it for a moment. What is the answer? Well, if you have a look at it, we're talking about the survivors. None of the survivors was returned to France because survivors wouldn't actually be buried because they're alive. They're not dead. They're not deceased. So that's the trick in that question. So none of them was returned to France because they were the survivors. They could actually go back to the USA. Quite an interesting one, I think. But there might be others that you have come across in your work and in your subjects and in other subjects perhaps, and in some of the examples that you've used yourself. So how should we as teachers facilitate problem-solving techniques? Well, there are a few guidelines from Woolfolk, which is the main reading I've used for this presentation, and that is to ask learners if they understand the problem and encourage them to see problems from different angles. Don't just hand them the solutions. I mean, let them do their own thinking, and support learners in developing systematic ways of considering alternatives, and then teach them those heuristics, those rule of thumb kinds of ways in which they can try and go about solving problems. There might be more ideas you can think about for solving problems. I don't know if there are any more, but I think one of the biggest stumbling blocks that we land up bumping our heads against is that we are making assumptions about the ways in which learners can solve problems. And if we are really going to be so open to allow them to solve problems in novel ways, we need to ourselves not be so fixed in our own mental sets. And we can't really make assumptions about what learners are able to do and what they're not able to do if we're following Vygotsky's kind of approach, because learners might be at different places and they're going to be using what they know to be able to solve those problems. So the other thing is to think about, do the learners have all the information they need? And if they don't have it, are they able to retrieve that information in some way? Another one would be to help them to visualize the problem, because sometimes by drawing a diagram makes it so much easier to be able to learn to solve a problem. And of course, the biggest way to know whether someone has fully understood something is to get them to explain it to someone else, so they can explain the problem or their solutions or their alternatives or whatever it may be to another member of the group. And that's a clear way to understand how much they understand the problems themselves. They can even talk out loud if they want to, to solve a problem. They can verbalize a problem, and often by verbalizing it, by saying it, whether it's in your mind or saying it like we might have done just now when we spoke about the survivors off the plane, it really helps you to see what the answer to the problem is all about. Some questions to consider after being through these approaches of inquiry-based learning and also problem-based learning is to think about how you could use these in various different subjects. Would you be able to use this approach in your subject or subjects? And if so, where and how would they be useful? Can you think of places where they would be useful, or is it something that you do a lot of within your particular subject? Would the ideal algorithm that we spoke about for problem solving actually work in your subject, or is it far too simple an approach? Or are there other kinds of approaches that you would use in problem solving? Are they particular to particular types of problems? But ultimately, of course, because we're doing this in the unit that deals with constructivist thinking, we need to think about how these concepts reflect constructivist thinking. And that is something that I want you to think about very carefully. We know that it involves active learning, as I said in the beginning, and we know that it involves working with others in a socially collaborative kind of mode. So that would very much fit in with constructivist thinking. But consider all the other elements that occur in these kinds of approaches and how that would echo a large part of what we mean by constructivist thinking approaches. And then lastly, how do these concepts relate to our South African scenario? So if we could, can we use them? Are they appropriate? And a question I have there is if we could use inquiry-based learning and problem solving in very under-resourced schools. And you need to think about reasons for your answer. And I want you to think about that because it's something that we're going to be talking about in our last week where we pull everything together. So think about that one in terms of its uses overall at various phases and stages in various subjects, with various types of learners in different kinds of situations, whether we can actually use these kinds of approaches very successfully or not. So in this slide, I'm just mentioning the 2 videos that I used to gain the information from, as well as my primary source, which is a book I happen to have at home. I'm not actually at the office at the moment, which is a book by Anita Woolfolk. And I know there have been many other editions of this book. It's a well-known educational psychology book, and it's a really good educational psychology book, which some of you may have access to, those of you who've studied psychology before. So with that, I want to end this section, and I want to say thank you very much for listening. I hope you've learned something new, and I look forward to us being able to discuss this particular approach in our very last session that we will have in this particular unit.